An object is placed in front of a converging lens. The lens has a focal length of f. This is f. The lens produces a real enlarged image. Enlarged image in which label position is the object. Here at D we have virtual. This is the focal length, we have virtual. At C, no image. At B, we have a real image, enlarged image here. At A, we have a real image but minimized. So the answer is B. What is the speed of electromagnetic wave in a vacuum? It's 3 times 10 power 8 means 3 and 8 zeros in front. 300,000 or 300 million. 1,000, so 300,000 kilometer per second. So the answer is C. As the starter in an athletics race fires the starting pistol, there is a wall 60 meters from the starter. Pick the speed of the sound 330. How long after firing the pistol does the starter hear and the echo of the sound from the wall? V equal distance over time, so time equals distance over V. T equal distance is 60 and for the echo 60 and 60 over velocity 336. The diagram shows the magnetic field around a conductor which is carrying a current. Where is the strength of the field greatest? Greatest when we have the separation is shorter. We have here the separation is less. As we go away, separation increases. So at A, where the separation is less. Remember that the separation between magnetic field lines indicates the strength of the magnetic field. A positive ion in a vacuum moves at a steady speed in a straight line. There is a potential difference between the two parallel metal plates P and Q, so that they are oppositely charged. When the positive ion enters the region between P and Q, it changes direction as shown. The diagram shows the view from above the ion. As you see, the positive ion deflected toward this plate P, which means plate P is negative, and of course plate Q will be positive. Which diagram shows the direction of the electric field between the plates? We know that the electric field direction from positive to negative. So we'll see here where the plates where we have from positive to from direction is upward. And the circuit shown, the voltmeter reads 2 volts. A charge of 5 coulomb passes through the resistor. A certain time. How much energy is supplied to the resistor in this time? Energy or work V equals W over Q. So the energy or work equals V times Q. V here 2 times Q, 5 equals 10 joules. Which graph shows the current voltage IV graph for the filament lamp? For the filament lamp, it obeys Ohm's law in the beginning, so it's straight line. in the beginning, but later, with the increase of voltage, the current does not increase because there's too much resistance. It increases. Okay, so it's not the graph, it's not the graph, this is the graph. It increases at the first straight line, then with increase in voltage, less increase in the current because of the resistance increases. So, yeah. Diagram shows an electric circuit. An electrical circuit. Which statement is correct? The current reading on the meter A1 is the highest. Of course, this is the battery here, and this is the total current in A, and the current is then divided between A2 and A3. So A1 equals A2 and A3. So the current reading on the meter A1 is the highest. This is correct. Current reading on the meter A2 is the highest. This is wrong. The current reading of A3 is the highest. Wrong. The current reading of all of them is the same. Also wrong. So A. Question 29. The diagram shows an arrangement of resistors in series and parallel. Which equation is used to calculate the combined resistance of the resistor? First, we have R2 and R3 in parallel, so the combined of them is R2 times R3 over R2 plus R3, and this is an R2 and R3 with R1 in series, so we add them R1 plus R2 times R3 over R2 plus R3. This is the answer. An electrical engineer has made a pair of components P and Q. The resistance of P decreases, so we have two resistance. P and Q. The resistance of P decreases as the temperature rises. Temperature rises, the resistance of P decreases. The resistance of Q increases as the temperature rises. The total resistance of P and Q remains constant when the temperature changes. R here is constant. The two components are connected in series with a power source supplying constant current. Which statement is correct? If the temperature changes causes the potential difference P across to double, the potential across Q will always halve. This can be right. If the potential difference here is double, the potential difference here must be decreases, but it's not a condition to always half. The difference, so we can consider this the correct answer. The difference between potential difference across P and the potential difference across Q not change with the temperature. V here constant and V here constant does not change with temperature. Of course not, because resistance changes here and changes here, so the potential difference also going to change with temperature. The potential difference across component P increases as the temperature rises. He said no, as resistance decreases, so the potential difference also decreases. So this one is wrong. The sum of potential difference of a B and the potential difference across Q does not change with the sum. Yes, sum is constant because the resistance or the sum of resistance is always constant, so the sum of potential difference also constant. So this one is correct.